Right. Hi everyone! Get excited. We're talking about roots and the fundamental theorem of algebra today. Alright, so what makes algebra algebra? So we have zeros, factors, roots, and intercepts. We have, what do we know about zeros, factors, roots, and intercepts? What have we seen in the previous lessons, okay, that we've worked on in school? We've got that a polynomial, right, it takes on this form. It starts with a sub n, and then it has its highest degree, and then the highest degree is going down in descending order all the way until the constant, if the constant exists. Right, remember that any of these terms, they could be not there, right? But again, it's just as long as it's from descending order, right? It starts with the highest degree and goes down. Then you know that, let's say I figured out when I factored this polynomial down, I got a number c after factoring. And that's where this c comes from. So this is after factoring, we get this number c. All right, when we set it equal to 0, this c pops up. All right, so c is a 0 of this polynomial right here. Let me see, can I get a pointer? Right, of this polynomial. Right, c is also, so if it's a 0, then what was the other word for it? Root, factors. It's a root. Let's just start with root, all right? Let's start with root for now. So if it's a 0, it's also a root, meaning that it is a solution when it's equal to 0, which is what I just said. So it's a 0 of it. And then along the lines of it being a root, we also discussed that it's also an x-intercept of the graph, all right? So especially if c is a real number, if that c that you get, that number, if it's a real number, meaning it's not imaginary, meaning there's no I associated to it. If it has no I, right next to its number c, then it's also an x-intercept of the graph, all right? So it's a 0, it's a root. If it's a real number, it's not imaginary, it's also an x-intercept. Okay, so it can be these three things. Now, if you have x minus c, so remember the binomial? The binomial, it is also a factor of this polynomial right here. It's also a factor of our polynomial. So whenever you solve it equal to 0, you can get the number itself, c, is a 0. C is a root or solution, right? Or it's a root. Or if it's a real number, it's an x-intercept. And if the binomial, all right, it all leads back down to 0, x minus c, the binomial, is equal to the factor of this polynomial. So all four things are equal. These are all equal statements. And that's what it says in this summary right here. So this is what we have learned before. Now, I'm going to make it bigger. The ultimate thing that we are looking at is the fundamental theorem of algebra. Alright? So, which states every polynomial equation with degree greater than 0 has at least one root in the set of complex numbers. Alright, so you might be thinking, why complex numbers? How come it's not real numbers? Well, remember, we talked about parabolas before. Alright, so we've talked about parabolas before. And parabolas, if I were to draw them, let's say it was like randomly in this quadrant 1 over here. You see, it never meets the x-axis. So because it never meets the x-axis, it has no real roots. So this parabola has no real roots. Right? And then, so if it has no real roots, then it has maybe imaginary roots. But that's why I can say that it's always going to be in the set of complex numbers. Oh, wow, that was really messy. But anyways, I'm trying to emphasize that it's always going to be, at least one of them is going to be in the set of complex numbers. Now remember, a real number can take on the form of a complex number. So a complex number takes on the form a plus bi. So a real number can be in the form of a complex number, but what does b equal? B would have to be equal to 0. So remember, a real number is in a different form when you have a plus 0i, right? And still, that is still in the set of the complex numbers, okay? All right, so that's the fundamental theorem of algebra. So if you have a polynomial with a degree greater than 0, meaning that the degree, so here's your polynomial right here, right? It starts with n degree here. N is greater than 0. Then you're looking at a root, at least one root in the set of complex numbers, right? So even if you had, all right, x plus 3, this is still a polynomial, but the polynomial is of degree 1. So brush up on your degrees of polynomials if this is like hard to grasp for you, all right? Because this is something we have talked about before, and this is definitely something you need to know before you move on to this lesson. So every polynomial equation with degree greater than 0 has at least one root in the set of complex numbers. So now moving on, let's go ahead and try an example here. All right, so this one we're going to solve the equation and state the number and type of roots. Okay, so let's see what we've got. So let's solve the equation. First things first. All right, x squared plus 2x minus 48 equals 0. I can factor this down into x, multiply what to get negative 48, but add them to get 2x, or 2. It's 6 times 8 is 48, so 6 times, or actually negative 6 plus 8 will give me what we're looking for. So it's x minus 6 times x plus 8, because 6 times 8, 48, and then if you subtract them, you'll get 2. Right? You got to keep this one negative, so you get the negative 48 right here. So let's see. So again, this is factoring. I'm going fast through it because this is something we've looked at before. So when you factor this, x minus 6 times x plus 8, this is going to be equal to 0 now. All right, and then solve the equation. So by the zero product property, which is just a big fancy name for setting each factorial or each of these binomials equal to 0. All right, and then solve. So x is equal to 6, x is equal to negative 8. All right, so I solved it. I have x equal to 6 and x equal to negative 8. Now, it says solve the equation. That was our first step. We did that. And then state the number and type of roots. Look at your polynomial. Here's your polynomial, which is your p of x. What is the highest degree over here? It's the squared right here. That's your highest degree. So the highest degree in here for this polynomial is 2. So this is a polynomial of degree 2. And by the fundamental theorem of algebra, I have to have at least one root in the set of complex numbers. All right? Okay? So, let's see. I have x equals 6, x equals negative 8, so I have two roots. And I can say that these two roots are reals, because remember, reals are also in the complex number set, because it's a plus 0i. All right? So my two roots are right here. These are my two roots. Because when you set it equal to 0, it's it was also, that was the first thing we talked about. It's a root. It's the solution to whenever the equation is equal to 0. It's x-intercept if they are real. All right. And we also call them zeros. Okay. So these are our two. We have two roots. And what type of roots are these? Well, this is just like a number plus 0i, so they are both real roots. And this would be our final answer. Okay, and you would box that. Right, so that was an example. Now moving on, the final thing I want to talk about is the corollary to the fundamental theorem of algebra, all right, which states a polynomial equation of degree n has exactly n roots in the set of complex numbers, including repeated roots, all right? So if I have a polynomial p of x, whatever degree this p of x takes on, right, we talked about it in class actually earlier. So p of x, whatever degree this has, so I'll say degree of p of x means that it has, all right, we'll call this is what they mean by n in the corollary. We'll call it degree of p of x, which is n. Then the number of roots that you have is also equal to n. And this is what we talked about earlier, that if we have x squared, we will always have two roots, right? For a parabolic equation, x squared, I don't know, plus 1. Right? This will always have the highest degree is 2, so it's a polynomial of degree 2. So the number of roots it will have, it will be 2. So the number of roots that this equation will have is 2. And it could be, and as long as, again, it's in the set of complex numbers, and again, complex numbers, it includes the reals, because a real is a plus 0i. It includes even, it's got imaginary plus the real part, all right? So again, it's the complex numbers. All right, girls, I hope this helped you out, and thank you for watching.